Hi everyone. This is just to give a clarity on this specific session, and I have already introduced Kimberly to the entire group. So as you're aware, it's SQLskills.com, and this has been a wait for us for a long time to hear from SQL Skills, and this is our first interaction, and we're really glad that Kimberly has accepted this presentation for us. And also the interesting topic about statement execution and the plan cache. This is one of the focus areas which we always wanted to listen to. And while others join, I think, Kimberly, we can give them another few minutes more while they join. We have more than close to 100 attendees now. I'm expecting 200 more. And also to give a brief about SQLskills.com, it's a team of experts on the core area of the data platform. And they are famous for all the research and a lot of support for the customers, and they do all kind of technical things across the SQL Server domain. And with that note, I would want to forward the presentation to Kimberly. And Kimberly, I think you want to also brief about yourself, and then that gives ample time for us to start.
Yeah, I've got slides for that, so I'm all ready.
Is it?
Yeah.
Then I think we're good to start then.
Okay. Thank you very much, Krishna. I really look forward to...
I'm going to mute my...
I'm sorry?
With that note, I'm going to mute my phone, so I think you can take over.
Perfect. Great. Thank you so much, Krishna.
Yep.
So I'm really looking forward to presenting to you this evening. This is probably one of my favorite topics because I find so many servers out there that are having problems dealing with the types of statements and the volume of statements that are coming through when not all of those statements should be submitted the way that they've been submitted. So I think this is a really good session to clarify the different types of ways that you can execute statements in SQL Server and how those statements actually work on the back end in terms of their plan cache and their optimization. So that's going to be the focus for tonight. I have a couple of marketing slides, as Krishna mentioned, and these will give you a little bit of background on the team. I'll just get through these fairly quickly so we can get into the technical stuff, and I will provide all of these slides so that you have all of the links and can click through and check out some things in depth to Krishna, so he'll distribute those however you normally do with your website and your user group. So you guys will have all of the content as well as the demos, so you guys will be able to reproduce what I demo tonight, because I'll also provide the sample database that I use. So as far as some background on the team, we are a team of folks that have been working with SQL Server for quite some time. Paul Randall, Glenn Berry, Jonathan Cahias, Aaron Stellato, Tim Redney, myself. And we tend to focus on architecture, performance tuning, a variety of kind of engine areas. And I tend to focus a lot on VLDB performance, so very large databases, partitioning, indexing, statistics, and often what goes hand in hand with that is why are my statements not using these indexes, or why are my statements not performing very well. And so I tend to do a lot in terms of optimizing procedural code and dealing with statement execution and plan cache, and that's one of the reasons why I like this session today so much. But these links will be accessible for you to click through and check out our online training. I know you guys are probably very familiar with Pluralsight. I'm going to give you a way to get a code from SQL Skills for 30 days of access to our SQL Skills content on Pluralsight. So I'll give you a way to do that, and that will also get you, more training if you're interested after our session is over. We also have an insider program. It just sends you 2 emails a month, a little bit of tech tips and insight into some of the resources that we have available, and we don't add you to any other mailing lists or anything like that, so it's literally just something to give you some tech tips and insight into kind of what's going on with SQL Skills, and like I said, we send those out about every 2 weeks. As far as our Emergent Events, I don't know how many of you can get to some of our in-person training. We don't have any currently in India, but we do have some in the UK and in Ireland, so that might be of interest for some of you. I know it's quite a ways to travel, but you can read a little bit about those with our in-person training on SQLskills.com. My background, like I said, is around VLDBs and performance tuning and architecture, and so it doesn't necessarily seem that statement execution goes hand in hand with that, but what often happens is we architect something, we create indexes, and then the questions come up, why is my code not using these indexes, or why is my performance not as optimal as I thought it should be? And so even though I tend to do a lot of architecture, the side effect of indexing and statistics is to make sure that the code and what you're doing is actually using those structures and indexes, and the way that you actually execute statements can help or hinder your ability to use certain indexes and certain plans. So it's really important to get some insight into how statements are executed and what's going on. So that's going to be the focus for me tonight. As far as our shows, we also have a spring show in Orlando. Again, I'm not sure how many of you guys travel out and go to some of these other events, but that might be interesting for you to check into, and I've got some links for that. And the last marketing slide is paul@sqlskills.com is who I want you to mail if you'd like to get a code that will give you access for 30 days to our content that's on Pluralsight. So, and there's no credit card needed, there's no catches, you just sign up for this free 30-day trial, and then after those 30 days you basically lose access, or you can sign up, but you don't have to provide a credit card or anything. They won't automatically bill you. And there are some courses kind of directly related to the content we're talking about tonight. In fact, I have a 7-hour course on statement execution and the plan cache. I have a 7-hour Part 1 course on optimizing stored procedure performance, and then I have a 4-hour Part 2 course, and I'll reference a couple things because I will end up not being able to cover 12 hours of content in our hour and a half this evening. So there will be a couple of times where I'll mention if you're more interested in topics around X or Y or Z, then it's in one of those courses. And like I said, if you send email to Paul, he'll give you a code that will give you 30 days of access to our content on Pluralsight. So you can see our library with that link at the bottom, and you'll be able to click through with the slide deck that I give to Krishna. So let's get into the content. This is the good stuff for me. I generally time this session at about 75 minutes, and I'm happy to take questions. So we'll see kind of what we want to do for that at the end. Actually, Krishna, I didn't ask you, is there a chat window that you're monitoring for questions, or are we just going to go through the presentation and stop there? I don't know if you can come back on and let me know.
I'm already monitoring the chat window in parallel, so I'll be letting you know if there's any questions on that across.
Okay, if I can see the chat window, then I can also look at it, but I don't see it in my list. So I see the general chat window, but I don't see. Okay, yeah, I see. You just did that to the entire audience. Now I see that. Okay, so good. Let me see if I can make it larger. Yep, okay. So now I can see as well. If a lot of questions, just to the folks out there, if a lot of questions start coming in, it sometimes gets a little bit harder for me to monitor it, but I do have multiple windows that I use, so I can sometimes see the questions and try to respond to them during the session. But Krishna, that's great if you're monitoring that too, so thank you very much. Okay, so in terms of the presentation itself, there are different ways to execute statements. So the first thing I want to do is clarify what I mean by these different ways to execute statements and what kind of impact those different execution methods have on caching and plan reuse. I'll talk about something that's known as statement AutoParameterization, when that occurs and when that doesn't occur. I'll compare ad hoc statements to SP execute SQL-based statements. I'll talk about literals, variables, and parameters and make sure all of this stuff kind of comes together and is clarified for you, because I'm positive that people run into problems with this because it's not very intuitive how these different methods work and the impacts that they have. So this is definitely one of these kind of eye-opener types of sessions. So starting with the different ways to execute. In terms of SQL statements, you can submit a statement that's ad hoc. So what I mean by that, very simply, is just, a select statement, maybe from Management Studio, and you hit execute. That is, simply put, an ad hoc statement. You're submitting the statement to SQL Server. SQL Server is going to receive that statement, parse it, it's going to optimize, compile, and execute. Now, as a side effect, and sometimes marketing talks about this, that statement can be auto-parameterized. It's not just even auto-parameterization, though, because almost all of your statements do get parameterized. But they talk about statements that get auto-parameterized as being cached and reused. And they make it sound like that's a really good thing. And while there are some positives for certain types of statements, it's not always positive for all types of statements. And that's what I'm going to clarify. I'm going to demo that for you, and I'm going to show you what I mean by kind of good statements and bad statements for the different statement execution methods. Now, what's really interesting is ad hoc statements are the way that dynamic strings are treated. So what I mean by dynamic strings is a statement that's constructed dynamically, and then you pass that into the execute statement. So you say execute string. So for all intents and purposes, these two statement execution methods are really the same thing, because a string that's executed dynamically is really a string that is then sent to SQL Server as an ad hoc statement. So then that statement is treated just like an ad hoc statement. They go through parsing, optimizing, compiling, and executing. But just like an ad hoc statement, that statement could be parameterized, and it could even be a statement that's already been executed and we're reusing it. So I'm going to make sure that's really clear when I talk about ad hoc statements and the types of ad hoc statements that can be auto-parameterized and can be reused. So that's true for dynamic strings as well. So these really behave exactly the same way. Now, the other ones listed on this slide, SP execute SQL, or a prepared statement submitted from a client application, or even a stored procedure, for the most part, these guys all work and execute and act in terms of plan caching the same way. So I'm going to show you and define what I mean by that. The simple term that I tend to use is called forced statement caching. And what that means is the statement that you submitted to SP execute SQL is essentially forced into the cache, and that statement is then reused for subsequent executions. And that is actually the same way that a stored procedure works. That stored procedure essentially goes into the cache, and subsequent executions tend to use the plans that were chosen when that procedure's statements were initially put into the cache. So I'll talk about, when does it go into the cache, when does it fall out of the cache, and certain considerations around these statement execution methods. So let me start with ad hoc statements. These two, like I said, behave exactly the same way. So when I start to describe this in more detail, I really am talking all the same for ad hoc and dynamic strings. And then when I get to SP execute SQL, that behavior is going to be the same for like SP prepare based statements that you might submit through your client application. So it's important to realize that, because the behaviors of exec and a string and SP execute SQL are very different, even though they're often compared to each other. And that's kind of a danger that some people fall into, is they think they're the same and they're not. So that's one of the things I'm really going to clarify here. So let me start with ad hoc statements. Ad hoc statements and dynamic strings, as I mentioned, essentially get evaluated at runtime. Now, the first thing that essentially happens at evaluation is they look to see if that statement has already executed. Is there already a parameterized version of that statement that's in the cache? So the question starts to become, well, when would that happen? When would SQL Server have taken an ad hoc statement, parameterized it, and put it into the cache? And the term that Microsoft uses is that if the statement is deemed safe. I tend to say if that statement is very simple, then it can be determined by SQL Server as a safe statement. If it's safe, then not only will it be parameterized, but it will also be cached. So what does that mean? I mean, what that means is that that statement's plan will go into memory, and the next person that executes won't have to go through the process of compilation. That can save both time and CPU cycles, so it can end up being a great thing when that statement is very consistent execution to execution with different values acting as parameters. So a good example is the one that's on the bottom of the slide. If I have a very simple select statement, select some columns from the member table, for example, where the member number equals 12, then what essentially happens is that select statement gets turned into a parameterized statement, and the parameter will be tied to the data type that we specified. So 12 is a tiny int. So now the parameter member number turns into parameter 1 as a tiny int, select blah, blah, blah from table where member number equals parameter 1. Now this statement, because it's so simple, SQL parameterizes it and determines that it is safe, so it then puts that statement with its plan into the cache so that subsequent executions can use that plan. The weird issue that occurs, and what I'm talking about is right here, is that those different data types that could be used, even though the statement is nice and simple and safe, you'll end up having a plan for each one of the data types that's submitted. So if somebody runs the exact same statement again, but they say where member number equals 278, that's not a tiny int, that's a small int, so you end up getting a plan and cache for small int, a plan and cache for int. But now if somebody else submits another small int, you'd execute that plan that's in cache again, right? And another small int again. So you'd start to get reuse out of that cached plan. So the positive is that you get that reuse, you save CPU, it doesn't actually put too much into the cache because it's only going to put that plan in there once, and that's where you get savings. But what I really need to define for a second here is how common is this? What is it and when is it that SQL Server defines a statement as safe? Because unfortunately it's not going to happen as much as you might think, because right now this sounds pretty cool, it just doesn't happen as often as you'd like. So more specifically, ad hoc statements and dynamic strings that get evaluated at runtime are probably not going to be safe. Even though I just talked about how kind of useful that is, and it is interesting, and marketing certainly likes to talk about this, especially when this first came out, but the problem is there's a bunch of limitations as to whether or not a statement can be deemed as safe. And unfortunately, the most frustrating limitation is the first one that I have listed here, and that's that the from clause cannot have more than one table. So if you start to think about that for a second, if a lot of your queries are joins, or they're even just a little bit more complicated, even if they only access one table, I mean, go through even just the couple other restrictions I have listed here. The where clause cannot have expressions that are joined with an or, so you can't use or. You can't have in. You can't use subqueries. And in fact, there's about 30 restrictions to whether or not a statement will be deemed safe. And the point is it probably won't be. And so what ends up happening when a statement isn't safe, then the unparameterized version of the statement with all of the specific literal values, that goes into the ad hoc plan cache for something called textual matching. But the problem is that you could be running thousands, select from a table where last name equals Tripp, select from a table where last name equals Randall, select star from a table where last name equals Caius. And the problem is that all of those plans start bloating the cache, and they are what we tend to refer to as single-use plans. They don't get reused, and they're effectively wasting your cache. So this is definitely a problem. You want to be careful with having what's often referred to as plan cache bloat. And I will come back to this, and I have a blog post series that you guys can get to that will also help you with trying to fix some of the problems associated with plan cache bloat. So like I said, I will come back to this, but it is important to realize this. But right now, the most important thing that I want to stress is that ad hoc statements and dynamic strings are most likely to be optimized on each execution because they're going to go into cache individually because they're really not likely to be safe, and that's going to end up costing you in CPU and compilation and bloated cache. So these can all be problematic. Now, what a lot of people start hearing about is this auto-parameterization thing. And I want to be clear that everything I've described so far is in the database default option for parameterization called simple. So this is something you can change, but before you go thinking that it's a good thing to change it, I usually do not recommend changing to forced parameterization until you've done some significant testing to see if you can really use it. And just to be clear, it's not even that common that you can use it unless you've done a lot of tuning in your environment and have very, what I call, stable and pretty consistent access methods to your server. Okay, so it's really important to realize, even though you can change from the simple parameterization mode, it's not recommended. So let me explain. Simple is the default, and like I said, it's a database option. If you were to change to forced, then SQL Server is going to work a lot harder, and it's going to throw out some of those rules that we looked at. However, there's still some statements that just cannot be forced. So the point that I'm kind of trying to make right now is the more that you know about the types of statements and your execution methods, the better off you're going to be choosing them more directly rather than kind of hitting the database with a sledgehammer database option that probably isn't appropriate for all of your statements. But just to be clear, if you have what we call stable plans, meaning you execute an ad hoc statement like thousands of times, you know, like last name equals Tripp, last name equals Randall, last name equals Cahias, and all those different executions you've tested, and you can see that they all have what we call the same query hash. So here's what I'm talking about now, the recommendation here. You can, inside a DMV called DMExec query stats, and I do a whole bunch of demos in my Pluralsight course on statement execution, so I'm not going to dwell a lot on this, but if you're really interested, you can query a DMV called DMExec query stats, and you can see all those, you know, 100,000 potentially statements that you executed. If they're in the cache right now, I mean, you have to have a lot of memory to see hundreds of thousands, but, you know, let's say you have 10,000 statements in your plan cache right now of one particular query. That query will, across all those 10,000 rows in DMExec query stats, they will have the same query hash. Then what you can check is how many query plan hashes, how many distinct values there are for the query plan hash column. And if a query hash has more than one query plan, what that's telling you is that that statement is not stable. But if you had one statement in the cache 1,000 times and all 1,000 executions have the same value for the query plan hash, then what you do know is that your statement is stable, even though SQL Server is not deeming it as safe. See, if it had deemed it as safe, it would have only put it in there once and it would have been reusing it. The problem is it didn't deem it as safe, so it's in there 1,000 times, but now you've just checked and it is in fact stable. Now, if your database option is forced for parameterization, it might be able to pick that statement up and force it in the cache so it's only in there once. But certain statements, even with parameterization forced, aren't forced. So my better recommendation is actually to take a statement that you know is stable and force it yourself by using a different execution method. Instead of using ad hoc methods, you can switch to a different method. So I'm going to show you that and give you some insight into the way that I would really do this. And I would do this more on a statement by statement basis, because for a lot of you, you might have tens of thousands of different statements, but there might turn out to only be 10 or 15 of them that are in fact actually stable. So taking those 10 or 15 and forcing them is a lot better than trying to force the database, which doesn't always work anyway, because there's still some limitations to what can be forced using forced parameterization. So this is where I'm going to start to show you some cool stuff. I have couple more slides, just so you can really understand this, and then I'll demo it. But dynamically constructed strings are those strings where you're passing the string into exec, right? And that string is not evaluated until runtime, and that string is then treated as an ad hoc statement. So we will look at that. Now, comparing and contrasting that, and dynamic strings, there's all sorts of other stuff. I mean, I could probably spend a half an hour just on dynamically constructed strings. I mean, these can be extremely large in size. They can be up to 2 gig for one statement. And that can be a very powerful way of building, especially a lot of administrative statements. A lot of people don't recommend this in client code because there are issues around security and SQL injection. However, I will also include a blog post link so that you guys can read this if you're interested. I wrote a blog post on ways to reduce and really eliminate SQL injection with dynamically constructed strings by following some patterns that I think are really important that you should use. So there is a discussion here on security, and I'm not saying to go crazy with dynamically constructed strings, but they can be useful and there can be some great uses of them. So all I really want to stress at this point is if you are using them, they are the same thing as an ad hoc statement. And the reason it's so important to stress that is that they are different from an SP execute based string. And I get a lot of people that say to me, wait, Kimberly, I thought these were the same thing. I thought exec and a dynamically constructed string is the same as dynamically constructing a string and then passing it into SP execute SQL. And the answer is no, they are not the same. See, exec with a string turns the statement into an ad hoc statement, whereas SP execute SQL is going to force a plan to be put into cache for the parameterized string that you have created and passed into SP execute SQL. So I'm going to show you a demo of this, and I'll make some sense out of this. So these are the scripts that I'll provide for you as well. I use a sample database called Credit, so I'll give you the link to download that. And this is a SQL CMD script. I don't know exactly where you're going to put the backup or what the name of your SQL Server instance is, and you can actually do a restore of this database because it's a 2008 database, so you can restore it to 2008, 2008 R2, 2012, 2014. So you're using a SQL CMD script and you put in your path and your instance name and your directory where you want it to restore, and then you'll restore Credit, and this is nice because then you can restore it over and over again and kind of play with it, tweak it. And then I've got these 2 scripts that I'm going to demo from. So this first one is about dynamically constructed strings passed to exec or to SP execute SQL. And what I first want to make sure of is that you don't have a you don't have a server option on called Optimize for Ad Hoc Workloads. So I'm going to select from it. Now I've already turned it off, but I'm going to select from Sys Configurations to see how it's set on my instance. And right now, it is not set. The value in use is 0. But if it is set, then you're going to use SP configure, essentially optimize for ad hoc workloads. SP configure only needs the number of characters that make that option unique, so you don't need to spell it out. And I'll run that. So that sets the value, and then reconfigure makes it take effect. But I really want to stress you should only be running these scripts, especially something like this, a server configuration option, on a test environment, which is, I think, obvious, but I just really want to say it's important that you're not doing this in production, because I generally and pretty strongly recommend this option to be on. And that's in that blog post sequence that I'm going to give you that helps you deal with a lot of ad hoc workloads. If a lot of you are using, link to SQL or a lot of applications that are dynamically constructing statements to SQL Server, then you'll definitely want Optimize for Ad Hoc Workloads turned on. I'm turning it off so that I can show you kind of the default cache behaviors. So all of these use my credit sample database, so I'll switch to credit. I'm going to turn my statistics IO on, so I'm going to start to show you what's interesting about the plans that I'm demoing. And I'm also going to end up turning show plan on in a minute, but I have a couple more things to do for setup. I'm going to do an update that sets last name to Tripp for one of the rows in the member table. So this is just going to change one row. You can see one row affected here. And then I'm going to create an index that could be useful to look up members by last name if I'm supplying a last name that is selective enough to use an index. So I'll create my index, and then I will look at the indexes that my table has. Now you can use just SP Help Index. I rewrote SP Help Index so that I could add a few extra cool things in it. In fact, it's almost a funny story. I actually rewrote that code on a flight from Hyderabad to LA on the way back from a trip that I had in India. I was so frustrated with SP Help Index. I'm like, I'm going to rewrite this, and that's a really long flight. So that was actually where I first rewrote this many, many moons ago. But so I'll show you what it does is it gives me the index IDs, whether or not those indexes are disabled, the names of those indexes, and the definition, like what the index keys are, as well as any included columns, whether or not there's a filter defined on the index. And then if you're really interested in getting into the index internals, I give you a little bit more insight into what's actually in the structure of the index. So not super relevant here, but I just wanted to point that out and let you know that I do have a last name index, right? So I can see that right here. The index was defined on last name, but behind the scenes, SQL Server also put the member number, which is the clustering key value, in the index as well. And that can be interesting. That can provide some other uses for that index. Not in this particular example, but just a little bit on the internals there. So now the question is, when I start to run statements, is there a way for me to actually see what the heck is going on in the cache? So I'm going to show you a query that I use quite often. I do a join, essentially, well, it's actually a cross-apply between dmexec query stats and the text of the SQL statement and the plan that's being used for that query. So from dmexec query stats, this is the DMV I was telling you about that has things like the query hash and the query plan hash, and I'll point those out on a couple of statements as well. You can end up seeing what the text is, seeing what the query plans are, and since I'm going to run this join and this cross apply so many times, I'm going to put it into a little wrapper of a procedure so I can just easily reuse it by passing in the string that I'm interested in. So I'm going to create that little procedure, and now I'm going to start my demo by first clearing my cache. And again, test servers, this is fine. These are multiple things I don't want you to do in a production environment, but this is clearing what we call the plan cache or the procedure cache for the entire server. So again, not great except in a test environment. So now I'm actually going to turn on statistics IO and statistics time, and I'm also going to turn on the graphical show plan. So that's this icon up here, include actual execution plan, or you can go over to query, include actual execution plan, and I'll start to show you how to read that. And I don't think I actually ran this. Okay, so now for sure these are all on. And now I'm going to run a statement, select star from member where member number equals. This is very similar to what I had in the slide a couple of minutes ago. Very simple, very safe, it's going to turn out statement. So I run it, and it comes back right away. I mean, most people would probably say, Kimberly, I wouldn't even be thinking about a statement like that because it ran so quickly. And I get that. But I bet that a lot of you are running on relatively good hardware these days, and you can tend to get away with a lot of code that's maybe not even that well written because your servers are fast, and even your development machines are pretty fast. And so I just want to stress, just because something comes back really quickly doesn't necessarily mean that it's as optimal as it could be. So there's other things I want you to kind of look at. Now, this particular example, we're going to go look at the execution plan, and we're going to see that SQL Server did a clustered index seek. To be honest, you really can't get much better than a clustered index seek, especially if it goes to just a single row. So if this is returning one row and you see a clustered index seek, there's really nothing that we have to do to optimize this any further. This is about as simple as it gets. And the reason why that's interesting is if I run it again with 3, 4, 5, 6, 7, execute, I go look at the plan, and again, I see the clustered index seek. And maybe I start to think, looking at the select statement here, right, it says select star from member where member number equals, and it has that parameter 1. So you might even think that this is parameterized, right? So what I want to stress here is all of your statements might look like this, but just because it shows like this doesn't guarantee that it's been cached as a parameterized statement. Now this one has, but I'm going to show you one coming up that hasn't, and I'm going to show you how to tell. Okay, so I'm going to continue on with this though and show you another case where member equals 36. I run this, and again I see a clustered index seek, and I see that parameterized statement. So now the question is, what's in the cache? What's SQL Server doing? And I run my stored procedure, quick check on cache, and I pass in member. And sure enough, now there's some other things in the background that are running, but if I look at these first 3 statements, I see what I showed you on that slide earlier. The parameter 1 of type int for the statement, select star from member where member equals member number as parameter 1. And then I see that for the small int and the tiny int, and the important thing to realize too is that each one has only one execution. So I did not put these statements into cache and reuse them. However, I would if I were to run them, again, and it doesn't have to be such a close number. That was just an easy, quick way for me to put in a value. So I'll run a couple of those, and then we'll do a quick check on cache again, and you can see that I am in fact using that statements plan again and again and again because the execution count is going up. So this statement is auto-parameterized. That's the general term that you hear. But the coolest part is that not only did it get auto-parameterized, but its plan also got cached, and I am reusing it. So I can see that in the cache very easily by looking at those DMVs that I showed you. Now, what's also interesting, if I go to that quick check on cache, and I scroll a little bit further. So we're really interested in the first 3 rows here. So if I scroll, and it's kind of way over, so give me a second here, because it might take a second to show that on your screens as well. But if I scroll about 3/4 of the way over, do you see query hash and query plan hash? The query hash is exactly the same for all 3 of those statements. And more importantly, the query plan hash is also the same for all 3 of those statements. So it's a little bit not great that SQL Server is putting this query into cache over and over again because it's kind of wasting cache, but it's only wasting cache for a couple of statements. This is much better than when it puts every single execution in the cache individually. So AutoParameterization can be a good thing, but it just doesn't happen unless your statements are in fact really, really simple like these. And since many, and I would even argue most of your statements probably aren't this simple, then to be honest, it's probably not as great as it sounds. So let me show you what happens with another statement, and I'll give you some insight into some weird differences with these statements even though they look the same, like this one. Select star from member where last name equals Anderson. So you think about that for a second and you think, oh, well, they're just looking up one last name. Well, is Anderson a highly selective name, or is Anderson a very common name? And if it's a common name, then it might not be good to use an index. So let's see, if I run this, look at that, there's a whole bunch of rows. And if I go to the execution plan, this time I see a clustered index scan. And the reason is this query is just not selective enough to warrant using the index. Okay, that's fine. I mean, a table scan is not always a bad thing. If your queries are returning a lot of rows, a table scan might actually be the best method. So, okay. And if I run this query, select star from where last name equals Anderson again, I mean, that query looks exactly the same. And in fact, the plan looks the same. And check this out. I see the parameterized statement there. I see where last name equals parameter 1. So maybe I'm thinking that I just reused that plan from cache because it had exactly the same value. So let me show you. I'll put Anderson into my quick check on cache, and I'll show you that those two statements are actually in the cache separately. And the only difference between those statements is the space. So as weird as that might sound, when SQL Server puts a statement that's not deemed safe into the cache, it won't match that statement even with statements that are incredibly similar. It will only do what's called exact textual matching. So if there's a space or a tab or anything that's different with subsequent executions of that statement, it won't match that statement and it won't be able to reuse it. But more importantly, this statement also did not get parameterized. The only type of matching this kind of statement will have is exact textual matching. So even if I go to the same pattern of the statement, like equals Anderson, and I put equals Tripp, and I run that, and I do see again that it's parameterized, but it was not leveraging a cached plan, and you can pretty much immediately tell that just by the fact that the plan is different than what we saw before. If we had seen the same thing, then it might have been reusing the same plan, but there's still no guarantee. And you know how you can tell? I can go over to the properties window and I can end up looking at that statement. I can see that parameter list and I can end up seeing, is the parameter compiled value the same as the runtime value? And then you know that that plan was created for you. It's not a plan that was in cache created for someone else. So that's kind of interesting. If we were reusing a plan that was created for somebody else, like let me go back to this 567. Remember we had used that a few times. So I'll put in a 568, right? So again, this is a new value. I run that. I go to the execution plan window and I go to that select. I look at the parameter list and you can see right there, let me just zoom in and make sure it's really clear, that the compiled value is 258, even though the runtime value is 568. So that's telling us that we are leveraging a plan in cache and we are using a plan that is in the cache. So that's kind of interesting. And If it's interesting to you, the only types of plans that can be parameterized and reused are plans that are known as trivial plans. Really, really simple plans that access only one table. You can't have multiple tables in the from clause. You can't have an or. You can't have an in. You can't have a subquery. And there's actually a whole bunch of other rules as well. So the more complicated your statements are, the less likely it is that they'll leverage any form of parameterization. So continuing on, these statements that aren't getting parameterized because they aren't safe, I'll run a few more. So I can do select from member where last name equals Tripp. This one here, select from member where last name equals Anderson. You might be noticing that there's subtle differences in the statements, like on line 138, there's an alias, right? And the point I'm trying to make on some of these is these are all different statements, and they're going to turn out in some of these cases, actually all of these cases, I think, well, this one and this one might end up having the same query hash, but they might have different query plan hashes. And I'm going to show you this. So we can look at all these statements that are in the cache and start to see what's going on. So let me run a couple more, and I'll run one with like, and I'll say like Tripp. I'll say member as M, but like Tripp. And I'll do one that's really not very efficient at all. Select from member where last name like %E%. So I'll run all of these. And the most important thing is that I want to go check on cache. This time, let's look for anything that has the word last name in it so that we can see all these executions that I just ran. And some of the first things that you can see is all my execution counts are 1. Nothing got reused, even though, in fact, some of these are incredibly similar. In fact, they might only differ by the last name, but that doesn't matter because these statements were not parameterized. And because they weren't parameterized and reused, only their ad hoc and essentially textual version of the statement can be reused. And I'll scroll about 3/4 of the way, and I'll show you the query plan hash and the query hash, and you can see that some of the statements, in fact, do have the same query hash, but interestingly, they don't all have the same query plan hash. And that's part of the reasoning for why SQL doesn't determine that these statements are safe. And the answer is they're not. If they're generating different plans and SQL Server weren't generating the different plans, if it were just putting whatever plan it used first into the cache and forcing everybody else to use that, you could actually have performance problems as a result of that. So the fact that this statement was not deemed as safe is actually a good thing because it appears as though different values do need different plans, because you can see the same query hash has 2 plans, right? Lines 4 and 5 have one plan, whereas lines 1 and 6 have a different plan. So that's interesting. And what I'm trying to get at here is that these statements aren't safe and SQL Server treats them appropriately. And the ad hoc statements up here that are safe, SQL does save them, but the problem is it doesn't do that enough. So now what else can you do? You could switch to using SPExecute SQL. SPExecute SQL is where you are constructing a statement and actually putting in a placeholder for the parameter, and then when you pass that string to SPExecute SQL, you tell it what the data types and parameters are within your select statement. So this is the string. These are the data types, and they're strongly typed, so there's no question of is it a tiny int or is it a small int, no matter what value you're passing in, even though it might be a small int or it might be a tiny int. SQL is already going to have it typed as an int, so there's only going to have to be one plan in the cache, and everybody's going to be able to reuse that one plan. So SP Execute SQL is absolutely fantastic when you have a nice, stable, consistent statement. And anytime you do, then I would strongly recommend using SP Execute SQL instead of using an ad hoc statement. But the problem is you need to test and you need to be sure, because if you end up forcing a statement that's not stable, then you can actually cause performance problems. So we'll start with a stable statement like the one I executed, where all the query hashes had exactly the same query plan hash. So that's how you're testing. You might have that statement in the cache 1,000 times, but if all 1,000 of the executions have the same query plan hash, then absolutely that is a great statement to force into the cache using SP Execute SQL. So I'll do that with this first one. I'm forcing that statement into the cache, and it's going to end up doing our clustered index seek. And sure enough, if I run this a second time with a different value and a third time with yet another value, right? So I've run it a second time. The third case, there isn't a row. Doesn't actually matter. If I go check on cache using MNO as the string I'm looking for, I can see that I only have one copy of that statement in the cache, and that statement's been used 3 times. So this is going to save you CPU, it's going to save you cache, it's going to end up giving you better performance. But you really want to be careful that you only do this for something that's stable. So let me show you another statement. Now, if I take another statement, because maybe I didn't test or I just expected everything should be using SP Execute SQL, which is not true. Remember, if I run that statement as an ad hoc statement and I run it 10 times, I can easily see that the query hashes match and easily see that the query plan hashes don't. In fact, I just showed you that with the last name example. Remember? We looked at that, and I really want to stress this because this is the way that you test to see if your statement is right for this method. So I go to the cache, I see that query hash is the same for all of those executions, but then I see that the plans are not the same. So what that tells me is I should not be using SP Execute SQL, and now I'll show you why. If you use SP Execute SQL for a statement like what we just did, select from member where last name like the last name that we pass in, and let's say I run it with a varchar 15, which is the correct data type for last name, and in my first execution I run Tripp. Tripp is a highly selective value, and in fact the best plan to find the rows for Tripp is to use an index. So I run this, and sure enough I go look at the plan, and the plan says use the index. I'll zoom in. It says use the index on last name, right? So now this is the plan that's going to go into the cache. The plan says, okay, I should use the index on last name. So now going back over here, I go to the second execution, which is last name of Anderson, which if you remember, Anderson is not very selective, and when we ran it individually, it used a table scan. So now what's going to happen? So I run this, I go look at the plan, and I see it used the index. And we kind of wonder to ourselves, well, it still came back really quickly. Is that really a problem? I'll show you how you can tell, but not quite yet. I'm going to run this third one, %E%. I mean, come on, if I told you to go find all of the employees that had an E anywhere in their last name, that would be difficult. I mean, you'd really have to check every single row. I mean, this really requires a table scan, and yet if I look at the plan on this one, it's also using an index. So we start to think, okay, wait a minute. Let me run all 3 of these and see if there's any plan differences. And I go look at the execution plan, and I don't see any differences. And I'm scrolling kind of quickly. The first thing that kind of tells me there's no differences is I ran all 3 of them, and it's telling me all 3 of them are a third of my execution cost. And if all three of them are a third of my cost, then that would start to imply that they all had the same cost. And the reason why it thinks they're all the same is that all those numbers, all those percentages come from the estimated plan. The estimated plan was estimated on Tripp. And if I actually look at these in the IOs and in time, you'll start to see that they really aren't 33, 33, 33. The first thing that you'll see is that first one took only 4 IOs and 29 milliseconds. The second query took 773 IOs and 73 milliseconds. And the final one took 10,025 IOs and 114 milliseconds. See, on my machine, I can get away with a lot, and it's barely even registering. But clearly, these are not equal across the executions. So there's something that's kind of misleading here. And the misleading part, right, is that this execution plan and all of these percentages are tied to the estimated value. And in fact, if I go to that properties window, right, and I scroll to like the third one, and I look over at that select, I can see that the compiled value, which is where SQL Server gets all those estimates, was Tripp, even though the runtime value is %E%, and those values are very different, and in fact, I probably shouldn't have reused that plan. But I didn't have a choice, or I should say SQL Server wasn't given a choice because I forced SQL Server to cache that statement because I forced it with SP-execute-SQL. This statement isn't stable, and this statement shouldn't use SP-execute-SQL. It should just be ad hoc. So that's where we're at. There isn't kind of a single way to execute your statements that's always good. Sometimes it's good to use an ad hoc statement, but for statements that generate a nice, stable, consistent plan, those statements are really better if they're submitted using SP-execute-SQL. The problem that I tend to see is some environments tend to say everything should be ad hoc or everything should be using SP-execute-SQL, and unfortunately, saying everything or always is not correct here. You should only be using SP-execute-SQL when the statement's plan is nice and stable. But you absolutely should be doing this because you do get better performance and less of an impact on cache by using SP-execute-SQL. So I am a fan. You just need to use it in the right scenarios. So let me go back to the slides for a couple of minutes and make sure that this is all coming together. Just to reiterate, SP-execute-SQL is forced statement caching. It is fantastic. It is the correct way to execute if the statement's plan is stable, even across different executions. But as I just showed you, when a plan for a statement should vary across the execution because of the parameter values, you really do not want to force a plan to go into the cache because that plan might not be good for everyone, and the execution of a bad plan could cause you to do thousands and thousands of IOs. My table only had 10,000 rows. It was a little tiny table, and yet I was still seeing my queries go from 4 IOs to 700 IOs to 10,000 IOs, when in fact it shouldn't have been anywhere near that. So the point is you really want to test this and look at your queries and your query plan hashes before you force them, and only force those that have only a single query plan hash per query hash. So this is absolutely something that you guys will want to check, okay? Sorry about that. This is absolutely something that you guys will want to check and test before you end up forcing that statement. And just to be really clear, I know it sounds like SP-execute-SQL is like a dynamically constructed string, but it's not. Remember that exec of a string treats it as ad hoc, and only if it's safe does it get cached and reused. So you could argue that dynamically constructed strings are really just like building an ad hoc statement, and they're likely to be recompiled on every execution because most statements are not going to be safe. Now, what's really interesting, I think, for some of you, because I know you're wondering this, because I get this question a lot, so I'm kind of heading this question off by answering it with a slide. SP execute SQL is actually the same behavior that you guys get for stored procedures. So if you're starting to think, you know, this behavior sounds a lot like a concept you've heard of called parameter sniffing or parameter sensitivity, it is the same. In fact, I've just described exactly the same behavior. See, when I executed those statements with SP execute SQL, they took the parameter, they looked at that parameter, and they evaluated that parameter for its plan. That's called parameter sniffing. And a stored procedure can also look at the parameters that come in and determine the most optimal plan for those parameters. And just like SP execute SQL is good when the plan is stable, a stored procedure is good when the plan is stable. And reusing that nice stable plan is fantastic, right? As long as the different parameters that are passed don't warrant a plan change. So that's when it's actually a really good thing. But most people have heard of parameter sensitivity and parameter sniffing as really a problem, because if you're using a plan that was really optimized for somebody else's parameters, then it may in fact not be good for your parameters. And so what's really important to realize is that when you're using a stored procedure, just like SP execute SQL, not all plans should really be saved. So it's important to understand how to deal with this in stored procedures, and there are ways to deal with this. In fact, I've got a couple of slides, and then I'm going to point you to a couple of blog posts as well as a free download of a session that I did that you can watch to get some more insight as well. And then you can also watch the Pluralsight courses if you get the code from Paul. Don't forget to do that. I mean, all you have to do is send an email. He'll get you a code. And again, we don't put you on any mailing lists or anything. It's not, we're not trying to, you know, catch you out on something. But let me give you some insight into what's really going on in those stored procedures. The way that you guys submit code is either using literals, variables, or parameters. So I want to make sure that it makes sense what's actually being used inside of your code. A literal is just like I showed you guys. It's where you literally have that value, where that value is an actual value for that column or for that, you know, data type. Select star from member where member number equals 12. Now a variable is one that's declared in your code and then has that @ sign for your query. Now, to be honest, a parameter also has an @ sign, but I'm going to be very clear as to show you which is what. So far, you've just seen a literal and a variable. A parameter is a special case where you're passing something into some reusable code. So you saw the parameters with SP execute SQL. Parameters for a stored procedure happen here in the creates definition, whereas a variable happens here inside of the body of the stored procedure. So MNO is a variable, and I explain that right here. So when you go back to these slides, you'll remember all of these definitions. But MNO, I know they both look the same because they start with an @ sign, but MNO is essentially a variable. Parameter 1 is actually a parameter, and parameters can be sniffed. Parameters values are deemed what we call known to the optimizer. So we will end up being able to look at that value and optimize this statement right here. Okay? So sorry, my sketch is not perfect there, but select star from member where parameter 1 is the member number. That can be optimized. This is known. And the way that SQL Server does that is they use something called the histogram. Whereas member number, MNO, is unknown, and SQL Server cannot optimize as effectively, they have to use something in the statistics that's called the density vector, and the estimates you get from the density vector are averages across the whole table rather than specific values for a parameter. So often you can get a better plan when you sniff and actually optimize for that parameter. But here's the problem, right? The first person who ends up generating that plan into the cache, it's going to be their parameters that define what that stored procedures plan should do. So if subsequent executions have different parameter values, the plan that's in cache might not be good for everyone. And so it's important to realize that your stored procedure can have parameter sensitivity problems. And what some people will do is they'll actually use the trick of putting something into a variable so that they get, instead of a specific plan, they get a generic plan. So this is possibly a way for you guys to optimize, but there are a lot better ways to deal with stored procedures, and that's why I have a whole bunch of resources I'll point you to, including 11 hours of content on Pluralsight that I've done on stored procedures. So that might be really helpful for you to look at as well. So let me bring it together and give you some insight into why this is so important. These plans, they're not a short-term thing, right? These plans go into cache, and they might stay in cache for a long time. I mean, if you restart SQL Server or you flush the cache, if you change the schema of an object, or in most cases, if you do something like updating the statistics, then you will get a new plan in cache, right? So that could cause the plan to get kicked out, but most of those things are not things that happen really frequently. So once that plan kind of goes into the cache, subsequent executions tend to use that plan, and again, the question, is that a good thing or not? And the answer is it depends, right? It depends on whether or not that plan is good for all of the different parameters. And in some cases it might be, and in that case it's great. But in some cases it might not be, and if it's not, that could actually make your query plans horribly expensive and very slow. And it might be better to kick that plan out of cache and recompile it for every execution. So there are some ways that you can put like option recompile into your code to get SQL Server to do that. But again, I'm not doing all the stored procedure stuff here, but I will give you guys some great resources. I'll start with a blog post, then there's a free session that I did as part of PASS, and then I've got more content after that that you might be interested in. So let me bring it all together here. I'm getting pretty close to the end. I probably have about 10, 15 more minutes just to wrap things up. So the reason why all of this stuff, everything I've talked about today is so important, because a lot of people are like, why does she seem to care so much about, bloating my cache? And you might think these plans, they might be really, really small. And they are pretty small. Every plan is on an 8K boundary. So that means the smallest that a plan is 8K. And most of your plans are going to be 8, 16, 24K. And then as you get to more complicated statements, they could actually be megabytes in size. So you might think, okay, how long is it going to take for me to bloat up my cache with a plan that's only 8 or 16K? And really the answer is it might happen a lot sooner than you think, especially because a lot of you are consolidating your SQL servers onto virtual machines. And even though the physical machine that you're running on might have, 128 gig or 256 or 5 or even a terabyte of RAM, the actual SQL Server instances, if they've been virtualized, might have far less memory. In fact, I did all the math for you if you're interested. If you're running on 2005 SP2 and higher of SQL Server, so this applies to 2008, 2012, 2014, if you look at the cache, you'll actually see that if you're running on a really small virtual machine, like I'll basically say 16 gig or less. So if you're running on like a 4 gig virtual machine, then up to 3 gig of that memory can be allocated to plan cache, and they essentially favor plan cache over data cache, and they'll keep piling those plans into your plan cache wasting essentially your memory and not allowing it to be used for data cache. So this might cause you a lot more thrashing and a lot more problems. Now, as you get to larger memory bases, then you might not be wasting as much memory, but my argument is, why waste memory if you don't have to? And so I often look at my plan cache with some code, and I look at things like, is my plan cache filled with a whole bunch of single-use plans that have only been executed once? And if so, then what I might actually do is clear that plan cache, not all of my server's plan cache, but I might clear just my ad hoc plan cache. And I've actually written all that code to help you see what's in your plan cache, see if it's being used as single-use plan cache, and then clear just the single-use plan cache. And it's in a blog post series that I'm going to point you to. So I'm going to pull this all together with a whole bunch of resource links. But the most important thing is really just understanding these statement execution methods. Because if you get a really good grasp for how these different statements are executed, then you're already going to solve part of the problem by using the correct statement execution method. So to summarize this, oh, and just one more reminder for you guys. For those of you that are consolidating, it's really important to think about the smaller memory footprints that are 8 or 16 gig, because in those cases you could be using a lot of your cache and kind of wasting a lot of your cache for plans that are only getting used once. So there's basically a sequence of things that I want you to do. I actually don't even want you to put the plan in cache on the first use, and that's what that Optimize for Ad Hoc Workloads does. So that's kind of the first thing I tend to recommend. Turn that server option on. Then, in addition to that, because that will help, but it doesn't solve all of your problems, in addition to that, I want you to look at the cache and every so often clear the ad hoc plans if, let's say, more than, and you can set this because you can customize the code, like if you're on a 4 gig environment, I might say if more than 300 meg of my memory is allocated to single-use plans, clear my ad hoc plan cache so that I'm never wasting more than 300 meg. And then I might actually have it look every half hour to see. So this is something that you can actually code on your servers as an admin, and then have your server kind of self-checking the memory and not wasting so much memory. So there's some cool things that you can do to kind of solve this. So let's bring it all together with our statements. If a statement's optimal plan and that the plan that it should be using varies execution to execution, and this is easy to see. You run that statement 10 times as an ad hoc statement, all the statements have the same query hash, then you check, is the query plan hash the same? If it's the same, great, it's stable. But if it's not stable, then ad hoc statements are the better choice there. But if it is stable, then you can switch to using SP-execute SQL, which will be a nice, strongly typed, forced statement that will end up being cached and reused, which will give you some benefits. But having said that, all of this stuff is coming from the client application. So part of the question is, are you really interested in changing all of your client apps and doing all that work, and are your developers going to be, understanding, should it be ad hoc or should it be an SP-execute SQL statement? Because in a lot of cases, they just want to know which way they should use and execute the statement. So it can sometimes be hard. My preference, if you can, is to actually, for you as a developer or a DBA that really knows how to test with the methods I showed you today, instead you can put that code into a stored procedure, and then if you write that stored procedure, you can kind of choose, should the plan go into cache and get reused, and you choose that method when it's nice and stable, or if it's not, then you can put into that stored procedure option recompile, and that particular statement's plan will not be stored in the cache. And then you have this nice centralized code that you can leverage across different environments and reuse it. So my preference in general, if you can, is to use stored procedures. But it really depends on the environment as to whether or not you're going to be able to do this. So let me point you to a bunch of resources. I haven't seen any questions so far, but I'll stick around for questions. So I went through all these different ways to execute, talked about caching, talked about stored procedures, talked about the life of a plan. What I want you to do next, go back through this session, go through the slides, make sure that you feel kind of comfortable with this, play with the demos, send an email to Paul to get that 30-day trial of our content on Pluralsight. And then if you go to Pluralsight, the first thing that you could do is watch my Optimizing Ad Hoc Statement Performance course. That's the content that we discussed today in even more depth with more demos and all the stuff that I talked about clearing the cache and dealing with the cache and evaluating the cache and looking at query hashes and query plan hashes. I actually go into a huge amount of depth on that. Then, if you decide that you want to write stored procedures, which is my preference, you could go to parts 1 and 2. Part 1 is 7 hours on procedure caching and recompilation, and then part 2 goes into what happens with different session settings and a bunch of other fairly, I think, really helpful stuff. Now, plan caching resources, there's stuff on MSDN, there's a white paper on this, and there's actually a version of that white paper across the different releases of SQL Server. And my blog post series starts with plan, cache, and optimizing for ad hoc workloads. I talk about clearing the single-use plan cache bloat. So this shows you the code and how you can end up looking at what's in your cache, and if you're wasting a lot of your cache with single-use plans, it shows you how to clear that. I talk about the different methods for doing that. I really give you even more insight onto why you should use stored procedures. So then if you decide, yes, I want to use stored procedures, you can start with this blog post. Then you can watch my PASS Summit 2014 presentation, which is freely available on PASS TV, called Dealing with Multipurpose Procedures and Parameter Sensitivity Problems. And then you can continue there from there with my stored procedure blog post. In other words, there is a tremendous amount of even just free content that's available to you guys to really dive into this and get to understand this. And I promise you, if you feel really good with statement execution, you will get better performance on your servers because you're going to be doing things the right way and the more optimal way right from the start. And that is just the best way to work with your servers. So, well, you guys have been quite silent this evening, so I guess I'll open up the floor if there's any questions, Krishna. I haven't seen any come through the chat window, but maybe they've asked you directly.